Question number 97 on graph paper, draw quadrilateral MNPQ, and then it gives me coordinates here. This one is asking some very specific questions, and the reason is they're trying to guide me to think about some things. They want me to, kind of practice a few things and think about things. So let's go ahead and draw this quadrilateral, given the points that they listed here. So point M is located at 1 and then positive 7. There's M. The next point I have is N, which is at negative 2, positive 2. And P is at 3, negative 1. And then the final point is at 6, 4. 6 and then 4. And that is point number LMN. MNP, that's point Q. They were not alphabetical. So let me go ahead and grab the line tool and draw the line segments that connect those points. So with the lines drawn, it definitely looks like it's a special quadrilateral, perhaps even a square. Let's move on here. Question A, I believe it just asks us to find the slope of two segments, MN and NP. So here's MN. We want to find its slope. So if I'm at N, I'm going to have a rise of 1, 2, 3, 4, 5, 6, and a run of 1, 2, and 3. 1, 2, 3, 4, 5, 6, and a run of, oh, I missed it. Actually, I'm not going to point M, I'm going to a point slightly above it. 1, 2, 3. So I actually had a rise of 5 and a run of 3. So with a rise of 5 and a run of 3, this line has a slope of 5/3. That's its slope. For N, I'm going to go down from N to P. I'm going to go down 1, 2, 3, and I'm going to go over 1, 2, 3, 4, 5. So here I've got a rise of negative 3 and a run of 5 units. So this one has a slope of negative 3/5. And when I look at those two slopes, right, 5/3 and negative 3/5, I know that this angle right here, angle MNP, that's the labeled angle, starting at M, going to N, and then P, this angle has to be a right angle. So let's write that down. It says, what are the slopes? Well, let's see. MN had a slope of 5/3. And NP had a slope of negative 3/5. And what can I conclude? I would say, hey, since these are both opposite reciprocals of each other, they form a right angle. So this is a right angle. Next it says, what's the best name that you could give this triangle? Justify your answer. Well, let's look at some other slopes here, I guess. So if I'm going from P to Q, I have a rise of 1, 2, 3, 4, 5, and a run of 1, 2, 3. So this has the same slope as the side opposite. So these lines are parallel to each other. And from M to Q, I've got a rise of negative 3, and then 1, 2, 3, 4, 5. So this one has a slope of negative 3/5. So I have two pairs of opposite sides that are parallel. So definitely this is at least a parallelogram. And it is a parallelogram with one right angle in it. And if I look at the pairs of adjacent sides, you can see I've got negative 3/5 and 5/3. I've got negative 3/5 and 5/3. I've got negative 3/5 and 5/3. So it turns out all four of those angles are right angles. The other thing that's happening here is, grab this pointer tool. If I look at this, this has it's down 3 and then over 5, right? Down 3 over 5, that's 3/5. If I look at this one, this is this one's got a 3 and it's got a 5 on it also. This one has a 3 and a 5. This one has a, well, there's the 5 and the 3, a 3 and a 5. So what I'm saying is all of these side lengths of this quadrilateral, that is a parallelogram, they all have a 3 and a 5. And if I'm to take those numbers, right, 3 squared plus 5 squared, what I end up getting here is that these all are exactly the same length, right? Every single one of these sides is exactly the square root of 3 squared plus 5 squared, which is 9 plus 25, which means that they're 34. Every single side is the square root of 34. And since they're all square root of 34, they're congruent to each other. So I would say that I've got here a quadrilateral that is a parallelogram that has 4 right angles. Okay, so that means it could be a rectangle. But furthermore, because all the side lengths can be thought of as hypotenuses of a right triangle in which the legs are 3 and 5, they're all congruent to each other. So this is congruent, 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 congruent. So obviously this is a square. And I went ahead and wrote down what I would consider a nice justification, right? So my justification for this being a square is, since all 4 sides are root 34 units long, I can think 3 squared plus 5 squared. And all 4 angles are right angles, and that's because all pairs of adjacent sides have opposite reciprocal slopes. This is a square. Question C, which diagonal is longer? Explain how you know your answer is correct. Well, actually, in a square, the diagonals are the same length. So I would say neither is longer. And the reason is, in a square, the diagonals are congruent. They're equal in length. And actually, that's true of a rectangle also. Now, just because I said that, it's probably a good idea to, kind of verify that, because that's just me thinking about, I don't know what that is. But if I was to look at this particular diagonal here, that diagonal has, 2 sides. One is 2 units long, and the other one is, this many units long. So I've got 2, and I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 2 and an 8. So that diagonal, right, again, what have I done is I've made a small right triangle here. The diagonal from N to Q is 2 squared plus 8 squared, which is 4 plus 64. The diagonal is the square root of those, so the diagonal is the square root of 68. And I could do the exact same thing with the other one, right? So I'm here, this diagonal has got that, and then I've got the 2, and I've got the 8. So if I'm just thinking about that diagonal also, it would be root 68 also. So they're congruent because I happen to know that in a square the diagonals are the same length. That's also true of a rectangle. But I can also demonstrate this empirically by calculating what they are. The final question is, find the midpoint of segment MN. Okay, so if I want the midpoint here, obviously it's somewhere in the middle of these two. I can see if I start at point N, I'm going to change Y by 5 units. So instead of going all 5, I'm just going to go 2.5 units. So this line right here at 2.5 is important. And then as I change my x values, x is going from -3 to +1. So that x value is going to change by actually by 1.5 units. So it's going to come down here in the half also. So my midpoint is, going to be at exactly, well, I've put a dot right there where it is, right? It's going to be at exactly -1/2 for x and +4.5 for y. And I can get that also. Let me write down that answer. So I believe it's negative 1/2 for x. And you see, this is going to keep erasing. Negative 1/2 for x and 4, positive 4 and 1/2 for y. This is my midpoint. And I can also verify that by looking at points M and N up above in the original problem. So let's zoom this in so we can just focus on these. If I'm trying to find the midpoint of these 2 points, when I add 1 plus negative 2, I get negative 1, and half of that is negative 1/2. And when I add 7 and 2, when I add 7 and 2, 7, 8, that's 9. So the y values is 9 divided by 2. Well, if you look at that, that is exactly what we had below. That's negative 1/2, and then 9 divided by 2 is 4 and 1/2. So the midpoint of segment MN is negative 1/2, comma, 4 and 1/2. And that was a lot of problem, right? But that's basically everything we've got for question number, I think, 97.